All right, I wanted to go over lesson 3.1. I believe the video I have in YouTube is like 17 minutes long or something insane. There's really no reason for that. So in Unit 2, they were talking about limit, and they were kind of hinting that this is something called the derivative, but they're just really talking about it from the perspective of the limit side. Now we flip it and say, why do we do that? And we say it's because that's what a derivative is. They didn't have this in Unit 2. Now we do. So what it's saying is, here's our function. The derivative is given some point x, and you always do this with an x, and if x equals 2, then we plug that in after we're done doing all the algebra. Do it something like this. Plug in 2 later. It's got nothing to do with the h equals 0. That's just the whole slope thing. This would be f prime of x. And even that's not accurate. This would say the slope of this is f prime at 2. So that's another way to describe the derivative function. It's just the slope at a point. Sometimes it's slope at a whole line. That's a little different, but not the end of the world. So let's see what else we got here. Now they get into this domain thing. The domain of f can be smaller than the domain, f prime can be smaller than the domain of f. You don't have to worry about that, but the domain of a derivative can't be bigger than its original function. That'll pop up in integrals. You don't have to worry about that now. When we say a functional that's differentiable at every point is a differentiable function. X to the third is a differentiable function. There's not going to be any problems there. So f prime of x is, we'll do it the long way, limit as this h goes to 0, x plus h to the third minus x to the third over h. X plus h to the third is x to the third plus 2x squared h plus, nope, I don't have it off the top of my head. It's x squared plus 2xh plus h squared times x plus h, which is x to the third plus 2x squared h plus xh squared plus x squared h plus 2x h squared plus h to the third. Put it together and we get, cross that out, limit as h approaches 0, x to the third plus 3x squared h plus 3xh to the h squared. That's better. Coming back to me. Still got the minus x to the third, minus x to the third, all over h. Minus x to the third cancels. Get limit as h approaches 0. 3x squared h plus 3xh squared, all over h. Cancel, cancel, cancel. As h goes to 0, this term drops out. 3x squared, which is the other way to show it. So some of the ways we show derivative is f prime of x or dy dx, things like that. Shown you some of this in class already, so hopefully it's not brand spanking new. And we have one more way to show it, and then we'll do our best to confirm that you understand what the heck we're talking about. So another way to find a derivative, think about this. Here's your function. here is really a. So this point is a comma f of a. And then there's just some point over here, x comma f of x. Wow. And this gap we're going to call h. So we could also write this as the limit. Actually, we're not going to call the gap h. We don't need an h. As x approaches a, just saying this one's coming over to here. So the gap becomes infinitesimally small. And then it's just slope again. X minus a, f of x minus f of a. And it's another way to do it. And I only bring it up because you will see certain problems that really use this definition. So let's try it. What's f prime of x if our function is y equals square root of x? So let's go up here. Limit as x approaches some a, just like h before. We don't know what that is. F of x is square root of x minus square root of a over square root of x. No, pardon me, just x minus a. X minus a. So we plug in a, what do we get on the bottom? We get a 0. No good, no bueno. So we do something counterintuitive. And it's what I call a trick. Have you seen this trick before? No? All right, then better luck. But if you see the trick, then hey, you know what to do. Keep going. Limit as x approaches a. Distribute this out. They're conjugates, so the middle drops out. We get x minus a. X minus a times 1 over root x plus root a. Cancel. Now we can plug in a. Square root of a plus square root of a is 1 over 2 square root of a. So f prime of x equals that, equals the derivative of square root of x. Now, some of you might say, yeah, that's a nightmare. I just want to do the shortcut way that you showed us how to kind of cheat with that. And I say, absolutely. F of x equals square root of x, also known as x to the 1/2. Well, that's a fraction, so sure enough, the rule can't work. Why not? F prime of x, 1/2, x, subtract 1, negative 1/2, 1 over 2 square root of x. There it is. All right. You can do it either way. Definitely practice that problem. Make sure you're clear about it. You can do it with the other technique, but there's a lot more algebra to do. So just so we're clear, one last thing. Here I use my calculator, and I will show you this soon, to graph a function, some weird function. It's got two curves, so it's some sort of x to the third function, and its derivative. All right, what's the slope right here? And this is absolutely key to recognize where the horizontal tangents are, the peaks and the valleys. Right there, the slope is 0. So you come down and it hits at 0. That's right there. This is the function. This is the derivative of the function. Right here, the slope is pretty close to 0 and getting bigger. So right here, the slope is pretty close to 0 and getting bigger. Now, if you had to draw a graph, you could just draw whatever you want and say that's about right. Right here, the slope is negative and becoming more negative, and then it's becoming more positive, even though it's still negative. So from here to here, it's more negative, and then it's getting closer and closer, and then it's positive. So that is how a slope graph works. You're going to spend a lot of time in your near future analyzing this, and you're going to have to learn how to go forwards and backwards. It's not that big a deal, but it is challenging the first few times you do it. What saves me is go for the horizontal tangents, plug them in, say positive slope, so this is up here somewhere, say negative slope, this is down here somewhere, it's coming back to 0, so it's going to bottom out and go here. Right here we have something called a point of inflection, which we'll talk about when we get to second derivatives, but start getting ready for this. All right, that should do it. Good luck.